So with the continuity of logical instructions here, that next rotate instruction is RRC. So the meaning of this RRC means rotate accumulator right. So here as like RLC, here we have to rotate this accumulator content in the right side, and at the same time this is going to be modified this carry bit also. So we'll see their opcode first. So opcode for this instruction is RRC, and as like RLC, here also operand is not required. Operand is the accumulator register, which is the part of this instruction itself. So their code will be mentioned with the code of this RRC as like hex code. So here this operand we need to specify none, and now we can understand this instruction with the example here. So for example, if we are writing here RRC and let the data as a accumulator content, if we are taking here as a A7H, then how it will work here? So first of all, we will fill up here this A7 in this accumulator register. So this can be written 1 0 1 0. So this is here A, and for the 7 0 triple 1. So now as per the structure drawn here, you will see that this D0 bit is going to be modified, this D7 as well as this carry bit. So before execution of this instruction, let's say this carry flag is here as a 0. So this is the data here we have taken for this entire things. It is before execution of this instruction, we are assuming this accumulator register content as a A7H. So this accumulator content is A7H, and this carry flag initially it is reset here as a 0. So now whenever we will execute this RRC, it means when the microprocessor is going to execute this RRC instruction, then how the outcomes will come in the flag like in this accumulator register. So here this D7 is going to be shifted right side. It means that D1 data will come to the place of D0, and D2 data will come to this place of D1, D3 data will come to the place of D2, D4 data will come to the place of D3. Similarly, D5 data will come to this D4, D6 data will come to this D5, and D7 data will come to this D6, and at the place of D7, what the data it will come? The value of this D0 as a 1, it will come at the place of D7. So now after execution of this RRC, we will see here what the values it will come. So this D0 bit is 1 here. So carry flag will be 1 here. Carry will be updated as 1. Now this entire data is going to be shifted circular right one time. So here this will become 1. Then this will become here as a 1. Then this will become here as a 0. Then this will become here as a 0. Then this will become 1. And this will become 0, and this will become 1, and at the place of D7, D0 bit will come. So this will become here as a 1. So now if you will see that this 4-bit combination, it is how much? That 8 plus 4, 12, 12 plus 1 is 13. So this will become here as a hex equivalent, it will be D, and this will become here, this 4-bit will become here as a 0, 0, 1, 1. So this is here 3. So D3H. So the accumulator content after the execution of this instruction will be here as a D3H, and this carry flag is going to become here as a set like this. So how many times we will execute this RRC instruction? Accordingly, those many times this accumulator content is going to be shifting right side, and at the same time those many times this carry flag also is going to be modified as per this D0. So I hope this is clarified. Now we'll talk about their flags here. So in the note we can write down here, that sign, 0, parity, auxiliary carry are not affected. Who will affect? Only carry flag modified as per D naught, as per D naught. So this is very very important point here. And the second point is that by default this operand is accumulated register content itself. So that is the reason default operand we do not need to specify here as a part of this instruction. So that is the this operand, it means accumulator address is the part of this RRC code here. So whatever is the RRC opcode, so there itself that the accumulator register address will be mentioned as a part of this RRC opcode. So that is the reason operand is not required to specify here. And now we'll talk about their size. So with respect to size, if you see that this instruction is having only English alphabet, so their size will be 1 byte here. And as I had explained earlier instruction also for the RLC, here also that as a machine cycle it will take only opcode for this RRC from the memory chip, and that will be executed by this microprocessor. So as a machine cycle also it is required only one machine cycle, and that is named here as a opcode fetch machine cycle. And as we know that for the opcode fetch, this T states by default it will be 4 T state. So in this instruction what we have to careful that operand is not required to specify. By default this accumulator register content will become their operand. And then the second part is, as per the operation of this RRC, this entire accumulator content is going to be shifted right side by 1 times for this RRC. So how many times we will write this RRC, those many times this accumulator register content is going to be shifting right side. At the same time, for each circular shift or circular rotate, this carry flag also going to be modified. So D0 bit is going to be modified, this carry bit as well as this D7 bit, and in this fashion it will give the output for this accumulator content here. So I hope this instruction is much clarified by you, so that this can be used for the further, like for so many examinations, for giving the answer in the programming part also. So I hope you understand this instruction in the better way.